Hello everyone, welcome to the video tutorial for Mega Pro, a powerful Arduino-compatible board with focus on its 4 independent hardware UARTs. In this video tutorial, we shall develop a project from scratch which allows for using 4 onboard UARTs at the same time. 4 serial ports provide ample connectivity, control multiple stepper motors, control several DC motors using serial control, interface and control serial display modules, or connect other general purpose modules such as GSM or GPS. This lovely little board here is Arduino compatible Mega Pro board. Smaller footprint and with no headers on by default, it can be used as a general purpose embedded board in production versions. It says here on back, a T-Mega 2560 processor, CH340 USB drivers, power source as 7 to 9 volts with peak 18 volts, although I recommend 9 to 12 volts range. If you are using 5 volts or 3.3 volts power output, it gives out 800 milliamps. Bear in mind if you did use them power outputs, power up your board using external pins, not the USB power. Arduino Mega Pro is feature compatible with original Arduino Mega board. Arduino compatible Mega Pro is almost the half size of original Arduino Mega board with a desirable production ready layout. It has tons of useful features and inputs-outputs, which come at an undisputable cost-effective price as compared to original board, making it an attractive target for professional and hobbyist equally. Let's analyze an actual Arduino-compatible Mega Pro board. I have placed this board under the lens alongside a pound coin, so you can get some ideas on the size and form factor of this unique board. The board is shipped with headers, but they are not soldered to the board. This is actually a unique opportunity as the production-ready product may require this board in a different layout and setup. Programming is done via micro USB port. The driver used is CH340G. I had no difficulty installing and using this board first time on my computer. Let's discuss some important header pins. The input power is via V-in connection which accepts 9 to 12 volts DC. The next set of pins is ground. I am using Win and ground pin pair to power my board using a desktop DC power supply. There are 4 UARTs total on board, including the UART 0 which is used by USB uploads and Arduino IDE serial monitor program. UARTs 1 to 3 are available for general purpose usage. Each UART has RX and TX connections and they are 5 volt compliant. Each UART is hardware, which means it does not use any software resource time on board. Having 4 UARTs, I believe personally, is an extremely useful feature which makes this Mega Pro board super useful. Now let's talk about the USB interconnect cable and USB hub. I bought 4 USB to serial cables from Chinese merchandise website, with each one costing me around 3 Great British pounds. With shipping, my main motivation was the price, so long as the cables do their job. These cables are CH340G based Windows drivers, with no driver issues whatsoever at my site. The red line is plus 5 volts. It's an output, as I confirmed with a DMM, and doesn't require connection. Black is ground, green is transmit, and white is receive. The USB hub is a common 4-ports hub which I bought off eBay for I believe 10 pounds. There is nothing special or specific about the hub, so long it has 4 downstream slave USB ports and an upstream connection to PC. You may buy powered USB hubs, but I don't see the need. It is worth mentioning that I did not power my Mega Pro board from USB. I shall use 3 downstream USB connections for 3 USB cables and 4th one for mini USB connection to the board. Let's discuss the interconnect and board pinouts in more detail. Position reference your board with reset button and USB connection in top right. The first pin set on left side header is V input, which takes DC voltage from 9 to 12 volts. The next 2 lines are ground connections. I use these 2 pin pairs to power the board via a desktop DC power supply. UART 1 and 2 and 3 are located from D14 to D18 as RX and TX pairs. As I mentioned earlier, UART 0 is only available via serial monitor utility in Arduino IDE. I did try to make it work with USB to serial cable, but the TX line did not work. It is still a valid serial port, but seems like on fully accessible from serial monitor utility. I could have spent a bit more time debugging the UART 0 connection to the serial cable, but as it was working through the serial monitor, I decided not to dig deeper. If anyone knows how to get UART 0 to work with serial cables, then please let us know by adding to the comments. This is the final integrated setup with the serial cables connected to the Arduino compatible Mega Pro board. The headers have been soldered onto the board and micro USB cable connected to the programming port, which also serves as serial monitor input and output. Board has been powered by 12 volts supplied by a desktop power supply. It is a flexible power setup, and it does have a benefit of not overloading the USB port, especially when I am using all 4 USB downstream ports on an unpowered USB hub. Plus 12 volts and ground connections are hooked on by using micro clips, which are sturdy and discreet enough for this application. 3 USB cables are connected to the respective RX and TX lines. Ground lines are hooked using an extender header pin set, which I soldered hastily. I needed ground extension as there were not enough ground lines on board to use. Plus 5 volts output lines are redundant and left as is. All serial data cables plus programming cables are inserted into USB downstream ports. Make sure that you tie or glue down the USB hub as it shall fly under the strain of heavy 4 USB cables. The setup is simple, albeit all the cabling which makes it looks like complicated. This is rather crude version of the software that I programmed onto Mega board. When all serial cables are plugged in, they shall enumerate as serial ports on the target PC. Altogether, there shall be 4 COM ports. All I have done is, in the loop section, whenever there is an input data on serial port 1 to 3, I send it to the serial monitor with an identity text appended and send the acknowledged text back to the incoming serial port. The program is simple and robust and exercises all 4 Megaboard enumerated serial ports connected to the serial hub. This is a quick preview of program code. It sets up 4 serial ports at 9600 baud rate and continuously scans them for input. If any input data, it sends it to serial port 0 with ID text. This is a screenshot of 4 COM ports enumerated on my PC, with COM port number 4 being program port. This is a screenshot of serial port configuration in Putty software with 9600 baud rate and stop bit 1. Let's download the program code and test it in real setup. When I plugged in all serial ports, I didn't know which one is 1 or 2 or 3. I knew which one was the serial port 0 as I was using it to download the program. I had altogether 4 new COM ports enumerated in the settings, and order isn't important here. I then opened 3 independent Putty terminal sessions for 3 COM ports, apart from the programming serial port. I started the Arduino IDE and serial terminal. After that, I started typing single character onto the Putty terminal. I said single because I programmed the board for single character detection. You can program it for more complex themes and structures as long as foundation is all working. As I type in, you can see I get the character read back in serial monitor, and at the same time, there is an appended ID text which tells me where it is coming from. You may also notice the acknowledge going to the correct serial terminal session. This proves all 4 serial ports are working and uniquely identifiable and addressable. If you found the Arduino Mega serial port tutorial helpful, please support the channel by liking and subscribing for more electronics and embedded systems content.